Hey guys, and welcome to the final video for Chapter 1 of the Pre-Algebra program. It's Section 1.7 entitled Scatter Plots. And in this section, there's going to be a lot of reasoning and not a lot of computation. So hopefully you've been a little bit familiar with scatter plots in the past, but if not, hopefully we'll give you a good introduction. So in this section, we're going to determine whether a scatter plot of data has a positive or negative relationship or no relationship at all. And then we're also going to make a scattered plot and analyze the relationship. So scatter plots are a great way of organizing information. And oftentimes, when we're analyzing information, we can see trends once we plot them in a coordinate plane. So I've posted a couple of pictures here of what a positive correlation would look like. And if you can see this line drawn here, it looks like we have a line going up in a positive fashion. That would indicate a positive correlation. Again, the points don't hit exactly on the line, but you see the general idea of the line in there. So whenever we have a line in this first coordinate here, so whenever you see a line going up here in this first quadrant, that denotes a positive correlation or an increase. And similarly, if you see a line going down in this first quadrant, again, roughly, not exactly on the line, but in that direction, then that's going to indicate a negative correlation or a decrease. So when it goes down, it's negative or decreasing. And if it goes up, it's positive or increasing. But then sometimes we study information and there appears to be no line at all. It doesn't seem to be going up and it doesn't seem to be going down. I can't draw a line and connect the dots. So that, in this case, would indicate no relationship. So let's look at a couple of examples here using words. Okay, when looking at the speed of an airplane and the number of miles traveled in 5 hours, is it reasonable to think that as the speed increases, that the number of miles traveled will increase? Well, just as a sidebar, hopefully last year you worked a little bit with the formula D equals RT. D stands for distance, R is the rate, and T is the time. And we can use this to generate a few points and get an idea of what's happening here. So we know that the time is 5 hours. But let's say the rate at which the plane is traveling is 50 miles per hour. So this is the number I just inserted. Mind you, that's not very fast for an airplane. If the airplane is traveling at 50 miles per hour over 5 hours, that plane is going to travel 250 miles. What if the plane is traveling 100 miles an hour? Well, now the total miles is going to be 500 miles. And similarly, what if the plane was going 500 miles an hour? Then the total distance would be 2,500 miles. So what we see is that as these numbers are increasing, so are these. So as the rate increases, then the distance increases too. And you would see if we plotted these points, a somewhat positive correlation here. So for this example, the speed of an airplane and the number of miles traveled in 5 hours denotes a positive correlation. What about weight and shoe size? Hopefully this one is a little bit obvious. Let's take my nieces that are 120 pounds and they're triplets. One of them wears a size 7, one of them wears a size 8, and one of them wears a size 9. Okay, not too different. But my nephew also weighs 120 pounds, and he wears a size 14. So notice the variation in numbers when the weight hasn't changed at all. Similarly, you could think of a 6'5" football player who weighs 250 pounds and wears a size 14 shoe. Or a troll who weighs 250 pounds but only wears size 4. In this case, there is so much variation that this is no relation. Okay, our last example of this type, the outside temperature and a heating bill. So this one might just be easiest if we try to throw it in a graph. These are degrees, and then this is your heating bill. 20, 50, 100, 200. Okay, if it's 10 degrees outside, is it more likely that your heating bill is going to be $20, 150, 100? Probably closer to 200 if you live in a small house. That heat's going to run all the time because it's so cold outside, right? So the bill is going to be much higher. Similarly, when it's 20 degrees outside, although it's not going to run just quite as much, so maybe you save a little bit of money if it's 20 degrees. Similarly, at 30 degrees, still kind of chilly, but not costing quite as much money, doesn't have to work quite as hard. And as you see, as the temperature starts to warm, what's your heating bill going to look like when it's like 70 degrees outside? Pretty low. Hopefully you're not going to be running the heat at all at 70 degrees. And so what we see here is a negative relationship. As the temperature increases, your bill decreases. So this is a negative correlation. Okay, well, I want to do one other problem type for you, and that is when you're given a set of data, I want you to plot that on a coordinate plane, and then we're going to analyze it. So in this case, to spare you my poor handwriting, I typed it ahead of time. Here is my ordered pairs. So as you can see, I plotted all of these on this graph. And this is the amount of visitors to a beach and the average daily temperature. So your X value here is the daily temperature, and your Y is the number of visitors that visited the beach on that day. Okay, so I've plotted all of those, and I want you to do the same in your homework. And then the question is, do I see somewhat of a positive correlation here? Do I see somewhat of a negative correlation? Or is it kind of all over the place, denoting no relationship at all? And hopefully you guys can see slightly this increase here, which makes sense, right? As the average daily temperature goes up, probably the amount of people visiting the beach is also going to go up. So in this example, there is a positive correlation of the average daily temperature and the number of visitors to the beach. Okay, at this point I want you to finish your notes and open up to your section. Read through the examples and begin your assignment.